Hi, I am Umar Murtaza and welcome to Professional DevOps by Pact Publishing. I have more than 25 years of experience in system administration with implementing and commissioning of development, testing, and production environments. I have worked closely with development teams throughout the software lifecycle. I have hands-on experience with implementing DevOps. Also, I have conducted full-day workshops for professionals both on-site as well as off-site. Course overview. DevOps is the most widely used software engineering culture and practice that aims at software development and operation. It helps an organization deploy software more frequently while maintaining service stability and gaining the speed necessary for more innovation. There are plenty of tools and technology frameworks related to DevOps available in the market, but identifying the most suitable one according to your organizational need is a real challenge. Implementing configuration management, monitoring tools, information security, and compliance are more critical for any organization. Each section of this course will help you implement the DevOps culture in your professional environment. With the help of source control, continuous build, continuous integration, automated tests with quality control, and container technologies, this course will be a perfect guide to learn and apply DevOps in your organization. By the end of this course, you will be able to identify and choose appropriate tools and technology framework for implementing DevOps in your organization. Coming to the roadmap of the course. Section number 1. In this section, you will understand what is DevOps, what steps should be taken in setting up DevOps environment and culture at your organization. You will learn the DevOps lifecycle and understand DevOps tools for version control, configuration management, continuous integration, continuous delivery, continuous monitoring, testing, and continuous deployment. Section number 2. In this section, you will learn the working of Git, how much important is Git in DevOps lifecycle. For deployment, you will learn Vagrant, a tool which can deploy machine independent of the host operating system. You will also learn the importance of Docker-based deployment in the organizations, how efficiently you can manage Docker networking, and then a deep dive into some use cases. Section number 3. In this section, you will learn about configuration management for your underlying infrastructure using Chef, Puppet, and Ansible. You will learn different types of Ansible setups according to your organizational need, how to manage complex infrastructure, and automation of tasks using Ansible. You will also learn about configuring Jenkins with Git, triggering tasks from Jenkins when a code is submitted. You will learn how Kubernetes manage Docker containers cluster. In section number 4, you will learn about monitoring solutions you have in DevOps for your organization by exploring Monet and Nagios. You will learn about installation, configuration, and monitoring of your infrastructure using Nagios. Finally, section number 5. In this final section, you will learn about implementing DevOps best practices, which makes a stable and effective DevOps environment in your organization. You will learn implementing security solutions and explore tools for enabling security checks in different phases of DevOps lifecycle. Target audience. This course is for system administrators, solution architects, implementers, or any stakeholder working in the software lifecycle environment who want to understand the concept of building a DevOps environment and strategy from scratch. You need to have some basic understanding and some working experience with Linux and understanding of IT environment. However, no prior knowledge of DevOps is required. What will you learn from this course? By the end of this course, you will be able to implement complete DevOps lifecycle, implement DevOps using Docker containers. You'll be able to efficiently use continuous integration, continuous delivery, and continuous management tools. You'll be able to use configuration management tools like Chef, Puppet, and Ansible. You'll be able to work with container orchestration with best practices. Monitor the infrastructure with Nagios. You'll be able to implement security solutions in DevOps lifecycle. We know what lies ahead, so let's get started with the course. Introduction to DevOps and its lifecycle. What is DevOps? What need to do to excel at DevOps? Starting with what is DevOps? DevOps is a culture, principle, and process that automate and streamline the software development lifecycle from code development to production. Why not just agile methodology? Agile methodology has been a powerful tool but with a prominent limitation. Most significantly, it fails to address software delivery. Agile methodology practically stops when production deployment is started. That produces a huge gap between users, developers, and operations. Here comes DevOps into play and fill these important gaps by bridging the operation and the development teams. Software developers, QA teams, security, and IT operation teams are all integrated by DevOps. Apart from comparing it with agile methodology, DevOps has an enterprise capability that spans all stakeholders in an organization, including the one mentioned before, plus business owners, architects, designers, partners, and suppliers. Missing of any stakeholder will lead to an incomplete implementation of DevOps. DevOps principles and culture. Collaboration and communication across stakeholders. As mentioned before, that's the culture of DevOps. An organization may use the most efficient processes or tools. It all becomes useless if the people does not execute those processes and use those tools. Team leads need to work with their teams to create an environment and culture of collaboration and sharing. Building a DevOps culture is the core of DevOps adoption. Priority should be given to operation needs. Whenever a need is raised, the entire team of developers, testers, and operation engineers must treat such requests as priority with equal weighting as other backlog or development items. Code developers should be part of the diagnosis team and accessing the system to find a solution. Extending developers' involvement to even after the software is delivered into production is the essential DevOps principle. Improve coordination and shared responsibility. In DevOps, it's essential to minimize the formal communication between each group. It is important to establish a culture of shared responsibilities, complete interaction, and shared knowledge of every aspect of the project. Here in DevOps, teams are vertically organized such that they are fully accountable from concept to grave. In a DevOps culture, a strong focus is put on continuous improvement to minimize waste, optimize the speed, cost, and ease of delivery, and to continuously improve the product or services being offered. Continuous monitoring is extremely essential to identify and resolve issues before they become problematic and business critical applications are affected. Variety has an adversarial relationship with operations. Variety means too many variables, and every variable in turn comes with its own set of dependencies. Few variables result in a decrease in risk. Standardizing technology, architecture, tools, and processes has tremendous impact. It not only reduces risk but also paves the path for extreme automation. Automation is taken as the critical ingredient for DevOps success. Manual work is not only slow but also error prone because of human factor involved. Therefore, automation has obvious benefits. Automation encapsulates every possible manual step which can be automated, including developing and testing the code, deploying the test infrastructure, running end-to-end tests, deploying the code, collecting metrics from production, end-to-end orchestration of the DevOps pipeline. The goal is to constantly learn, assess, and analyze what works and what does not. Organizational visibility and a culture built on constant improvement is critical to a success of DevOps adoption. What do you need to do to excel at DevOps? In an organization, the capabilities of its people and its culture are important for a successful transformation. For making DevOps successful, a collaborative effort is required by cross-functional teams, and deep engagement between them is critically important. You should enforce that all teams should work together and make it a joint effort. Developers should not leave the burden of testing and deployment to the other departments. You should have a deep working knowledge of all the DevOps practices. Checklist of all the phases should be maintained and thoroughly followed. These practices and processes will be discussed in detail in the following sections. After knowing the DevOps practices in detail, assess your team's maturity level, identify the gaps, then work on improving the areas which needs improvement. Check how much your team has adopted DevOps practices and how efficiently they can implement it in their respective areas. DevOps pipeline puts your DevOps processes, practices, and philosophy into action. It's an end-to-end implementation of the DevOps workflow that establishes the repeatable processes from code development, check-in, automated testing, manual reviews, and deployment. Experiment, test, and innovate. Moving the DevOps should never be considered as done. Continue to learn and improve your processes. In our next video, we will discuss the new DevOps roles. New DevOps roles. DevOps roles can be categorized into 7 different roles, which can be listed as DevOps Architect, Evangelist, Core Release Manager, Automation Architect or an expert, Software Developer or Tester, QA Experience Assurance Professional, Security Engineer, Utility Technology Players. We will discuss these 7 roles in more details in the following slides. Starting with DevOps Architect Evangelist. She is the DevOps leader who is responsible for the success of all the DevOps processes and people. In order to make efficient, effective processes and standards, DevOps Architect uses maximum automation techniques. The DevOps Architect must have deep knowledge, hands-on experience, and a passion for making a difference in the DevOps lifecycle. Also, technical depth is necessary to provide advice for making appropriate technology choices and driving technical implementation. DevOps Architect should have a clear concept on the roadmaps to support automation that includes end-to-end test automation and tool strategies. She should oversee tools analysis and selection and implement test automation framework and approaches. Second one is Core Release Manager. Core Release Manager is essentially a project manager that understands the agile methodology. She is responsible for overall progress by measuring matrices on all tasks. Release managers work to address the management and coordination of the product from development through production. Release managers oversee the coordination, integration, and flow of development, testing, and deployment to support continuous delivery. They focus not just on creating but also maintaining the end-to-end application delivery tool chain. Then comes automation architect or an expert. Automation architect is responsible for finding the proper tools and implementing the processes that can automate any manual task as possible. Automation expert automates as many steps as possible to achieve the test coverage and confidence required for a quickly push to production. Automation expert should be well versed in software testing processes and tools such as unit testing, mock integration testing, test automation tools like Selenium. She should be an expert in scripting, which is needed to implement these automated test processes for each step in DevOps pipeline. Well, automation experts should not be solely responsible for automation. Every developer and tester should take the responsibility also. Automation expert provides the framework and expertise to enable developers to embed test automation as part of the continuous processes. The software developer or tester is at the heart of the DevOps organization. Traditional responsibilities such as coding, testing, infrastructure, and system administration are all part of software developer's role. Scope of responsibility for a developer spreads from development into testing and deployment phases. As mentioned before, the developers play an important role in operations area. When the system breaks in deployment, they are supposed to be in the diagnostics team as first respondent. They just cannot build code to a specification and throw it over to a QA team. User experience and QA monitors the release of new features and prioritize the user experience. They monitor the release of new features and prioritize the user experience. Not to be confused with someone who just finds and reports a bug. She is responsible for the user's experience and ensures that final product has all the features as in the original specifications. The current expectation of QA roles is to test functionality, but in DevOps, the role needs to evolve to include user experience testing. Security engineers' responsibility is to keep the corporation safe and in compliance. Need to work closely with everyone to ensure the integrity of corporate data. In DevOps mindset, security engineers work side by side with developers, embedding their recommendations much earlier on in the processes. Security engineers design and build advanced automated testing frameworks and integrate them into the DevOps pipeline. The DevOps environment requires a new kind of IT operations or system administrator who are involved in the development processes. These technology players are involved in sprint planning to ensure that service quality, asset management, or security are prioritized over what is defined by the business. They can operate effectively on multiple fronts such as development platforms, tools, networks, servers, and databases, and that are cross-functional to development and support departments. Our next video will be on DevOps lifecycle, continuous integration, configuration management, and continuous delivery. This video is on DevOps lifecycle, continuous integration, configuration management, and continuous delivery. Starting with the DevOps lifecycle. DevOps lifecycle is all about continuous. Compared to existing software lifecycles, DevOps comes with continuous and automated processes with minimizing human interaction. This makes software lifecycle efficient and less prone to possible human errors. Main categories or practices of DevOps include continuous integration, configuration management, continuous delivery, continuous monitoring, continuous testing, and continuous deployment. We'll go through these sections one by one, and in this video we will cover the continuous integration, configuration management, and continuous delivery. Rest of the three will be in the following video. Continuous integration. In continuous integration, it's required that developers need to integrate their code into a central repository which is available for all the developers. But all the code has to be checked in to that central repository, making it a process that consists of continuous compiling, testing, inspecting, and deploying the source code. Continuous integration environment, each check-in made by the developer is verified. This verification is done by either executing automated build periodically or at every commit done to the central repository. Verification gives us a quick feedback based on the result of build execution. With a successful build, all is well. But if the build is broken, then all the stakeholders, especially the actual developer, are notified to fix the problem. This method helps us to identify issues at a very early stage of development, where it's relatively easy to fix. In case if this is not followed and verification is done after a number of changes which has occurred over a number of weeks, then fixing the bug can take many days or even weeks. Continuous integration forces the developers to think differently during planning. They must divide functionality into smaller discrete bytes so that software not only works independently but can also be deployed safely in production with the rest of the application if needed. Before continuous integration, the process of integration was a major and a very difficult process. Developers normally used to code in their local environments, and when integration was needed, another exercise of rewriting the code was required to get all the sections of the application to work. Configuration management. Configuration management tools are used for automating the application of configuration states. Like any other tools, they are designed to solve certain problems in certain ways. With the help of configuration management tools, you can make changes very quickly. As we mentioned before, configuration management is used to manage changes in the system or the server runtime environment. Configuration management helps in managing multiple servers at one time with similar or different type of configurations. As an example, when you need to install a web server like Apache or Tomcat on multiple servers with identical configurations, you can do it manually, but that will take time as well as there are chances of human errors. Configuration management tools helps us to automatically make the required changes on single or multiple machines on the fly. CM also keeps track or versions of details related to servers. Centralized server can trigger these changes and apply it on all the relevant servers, and where needed, entire installation and modification isn't applied again. Rather, changes in consideration are only applied. There are a number of CM tools available. Some have server and client installations, and others require only 7 installations, and no client software is needed on the target machines or nodes. Under all type of CM tools, builds are scripted with no manual interaction, thus reducing the time as well as making the process efficient through automation. Same build scripts are used to build development as well as production machines, thus keeping both type of machines identical. This is done so that any unexpected issues or errors are not experienced in the production machines. Continuous delivery. In continuous delivery, all the steps of developing, building, testing, and deployment is done automatically. But the deployment into production is done when the business is ready for it. Continuous delivery is a process of deploying an application in an automated fashion and providing continuous feedback to improve its quality. The goal of continuous delivery is to deliver incremental or small changes quickly and continuously as they go through the pipeline. This not only helps distributed micro features more rapidly, but also reduces the risk of a large release failing. In each sprint, the team develops features changes for the software, but the complete story must wait for the other stories to be finished and grouped together to be deployed in a scheduled release. Continuous delivery simply means that every change is ready to be deployed to production as soon as automated testing validates it. This completes our video, and the next one we'll follow will be DevOps lifecycle, in which we'll study the continuous monitoring, testing, and deployment. DevOps lifecycle, we'll be discussing continuous monitoring, testing, and deployment. Starting with continuous monitoring. Monitoring begins with Sprint 1 and should be integrated into the development work. As the system is built, monitoring solutions are also designed. Events coming from all computing resources, storage, and network are to be monitored. It doesn't have to be specifically for the applications, but for the hardware and for the infrastructure resources that need to be monitored. Application performance monitoring. Target bottlenecks in the application's framework. AppDynamics and New Relic are industry-leading APM tools. Log management monitoring. Collect performance logs in a standardized way and use analytics to identify application and system problems. Splunk and ELK are the leading products in this area. On security monitoring, security configuration management, vulnerability management, and intelligence to detect attacks and breaches before they do serious damage are achieved through continuous monitoring. Continuous monitoring can be divided into three major steps. First of all is monitoring. You have to monitor the infrastructure, you have to monitor the application, getting the alerts from there. Create an alert system to warn the team about the problem. Implement automatic elevation in case the first respondent does not respond. Actions to take. Actions to take when an alert occurs. All alerts should be captured and reviewed. For example, false negative alarm should be reported to continuous monitoring tools so that if it happens again, alert is not generated. Continuous testing. In continuous testing, automated tests are executed as part of the DevOps pipeline in order to obtain feedback on the business risk associated with the software. Continuous testing is about fast and a continuous feedback, but making it quick and not compromising on quality is extremely important. In DevOps, testing is involved in many processes of DevOps. Slight changes in the code is also tested. This helps in identifying bugs earlier where it's simple to fix. Automation is the key for DevOps. So all the tests possible must be automated, which helps to avoid human errors and are fast to get executed. With continuous testing, tests have to be atomic, which means they are small, independent units. They cannot have dependencies with other tests. Otherwise, you will have a large amounts of refactoring when small changes are made. With small tests, you are able to identify them and easily determine when and where to run them. Developers should begin continuous testing with testing performance and functionality of the code that they develop. They can use open source tools like Selenium for testing. Continuous testing gives the confidence to release the code at any time, since the code is being continuously tested. Continuous testing plays a vital role in continuous integration. Plugging in these tests and not disturbing the pipeline is critically important. Continuous deployment. Continuous deployment is the ultimate goal for a modern, efficient organizations. Continuous deployment can be called as a superset of continuous delivery. All the steps taken during continuous delivery is done here. Coding, testing, deploying, refactoring, all these processes are implemented in deployment phase 2. Unlike continuous delivery, continuous deployment is deploying an application with the latest changes to the production environment. Continuous deployment automates the application deployment pipeline, integrates with popular configuration management tools, and automates environment provisioning. In section number 2, you will learn the working of Git and its importance in DevOps lifecycle. For deployment, you will learn Vagrant, and then you will learn the importance of Docker-based deployments. Finally, a deep dive into Docker's practices. Section number 2, exploring Git, Vagrant, and Docker. Software configuration management tools, and we'll be exploring Git. In this video, we will cover overview of the version control, what is Git and its working, installation of Git, and before going further, we will step towards GitHub, get its overview and how an account is created on GitHub. And at the end, Git operations and its workflow. Starting with what exactly is version control. Version control is a multi-user version management system that manages the changes you make in your project, which can be an addition of files, changing or modifying the files, deleting the files, and then finally saving them. This process is done several times by a user or a developer. These changes are saved in the version control system as snapshots. Version control keeps track of all the changes referenced as version numbers. That include when the changes were done, who made the changes, why was it done, and contents of the changes. Some of the mostly used configuration management tools are Apache's Subversion system, which is called as SVN, Concurrent Version System, CVS, Git, and Mercurial. In this video, we will be exploring Git and its working. What is Git? Git is a distributed version control system. It's not centralized like other older versions, which were SVN and CVS. It does have a remote repository to which the users connect to it and pull their code from the remote repository and have it on the local repository. Whatever the changes the user is doing it on the local repository. So that means you don't need to have a connection with the remote repository all the time. Operations normally done is pull, edit, commit, and push. Another concept is of branching in Git, in which the master branch remains the same, and if some developer or a team needs to test a feature, then they create a branch for those specific features and start working on it without disturbing the master branch. Once working on the feature branch is complete, it can be merged back to the master branch. We have a remote repository. Two users are concurrently working on the remote repository. They pull their code and have it on their own local repository and start working on it. Once they are finished with their code, they can push it back to the remote repository, downloading and installing Git. Homepage of Git is git-scm.com. This is the home page of Git. If you scroll down to its download page, let's go to the downloads. We'll be using Linux. The command you need to give is apt-get install git. Before installing any package on your Linux machine, you should give this command of apt-get update. This is updating the apt repository on your Linux machine. Now, in order to install Git, you need to give the command apt-get install git. So the next step is to configure Git with username and email. For that, we need to give this command. Now let's move to GitHub, a slight overview of it, and creating an account on Git. GitHub is a repository hosting service. It has a web-based graphical interface, provides access control. It has unlimited public repositories, limited private repositories, and you can have a number of collaborators on the plans which GitHub gives you. And you have organizational accounts option also. For creating an account, go to github.com. You need to give your username, an email address, and a password. In Git operations, what we will cover is, first of all, we'll be initiating a local Git repository, linking it with the GitHub on the internet, adding files, branching it, merging it, pushing it to the GitHub. Let's create a directory, my project. Let's move into it. It will initialize it as a Git repository. So in the Git operations, we have initiated our Git repository. Now we will be linking it with the GitHub. Git remote add origin, and within the inverted commas, we'll give the location of the project. On GitHub, I have created a project by the name of Git training. So this will be the complete command. So your origin has been added, which is on GitHub. This command will pull the repository, which we have mentioned up there. The only file over there was readme.md. Now, if we create a file that is contacts.html, this will be listed in your current folder. Now, the Git status will show you that there is one untracked file, which is contacts.html, which we just created it. Now, there is no untracked file, but there is one new file over there. That means something has been added. It has reached to the staging area. It goes with git commit -m, and in inverted commas, you type in the message what exactly is being done, that you have added a contacts.html file. If we check the status again, so everything is clean over here. You are on the branch master, nothing to commit. There is no any change on your local system which has not been committed. So using the touch command, we have added 2 more files. Now check git status. By giving the command git add -a, multiple files can be added. Now git status shows that these 2 new files have been added. After adding a file, we need to give the commit. Git commit -n and the text. 2 files have been changed. Now shows that nothing is there to be committed. So we have done the adding of files. Now the next step we'll do is branching it. Git branch and the branch name, which I'm using it as branch 1. Once the branch is created, go to that branch, you need to give the checkout command. If we do ls, now we have contacts, people, services. These were the files which we inherited from the master branch, and another file support.html we have created in branch 1. Git status shows you that one new file is created and commit is needed. So in the message we are mentioning it that we have added support.html in branch 1. Now let's move on to master. Now we are in the master branch. If we do ls, here you don't see the support file which was created in the branch 1. So after doing the branching, we'll be merging our branch to the master file. Since we'll be merging the branch into the master, so we need to be in the master branch. With this command, we are merging branch 1 into the master. One file was changed, that is support.html. If we do ls over here, now we have that support.html file here. And at the end, we will push our code to GitHub. We generate an SSH key locally over here, and that public key we will post it onto the GitHub account so that we are able to push our code from the local repository to the GitHub account. SSH key gen will generate those keys. We will copy this key from here. Here on GitHub, we go to settings, SSH and GPG keys. We'll add a new key. Just name it as SSH1 and paste the key over here. finally add SSH key. In order to test that our keys are working, this is the command we give. You are successfully authenticated by GitHub. The command we'll be needing it is as git push origin to master. So once you have done the push, go back to your GitHub account and go to this repository, and over here you'll see all the files which were added locally in our local repository has now been available here at Git. So these are the processes which form a Git flow. So in the next video, we'll be on Vagrant, which gives a lightweight, reproducible and portable development environments. Section number 2, exploring Git, Vagrant and Docker. Software configuration management tools, and we'll be exploring Git. In this video, we will cover overview of the version control, what is Git and its working, installation of Git, and before going further, we will step towards GitHub, get its overview and how an account is created on GitHub. And at the end, Git operations and its workflow. Starting with what exactly is version control. Version control is a multi-user version management system that manages the changes you make in your project, which can be an addition of files, changing or modifying the files, deleting the files, and then finally saving them. This process is done several times by a user or a developer. These changes are saved in the version control system as snapshots. Version control keeps track of all the changes referenced as version numbers. That include when the changes were done, who made the changes, why was it done, and contents of the changes. Some of the mostly used configuration management tools are Apache's Subversion system, which is called as SVN, Concurrent Version System, CVS, Git, and Mercurial. In this video, we will be exploring Git and its working. What is Git? Git is a distributed version control system. It's not centralized like other older versions, which were SVN and CVS. It does have a remote repository to which the users connect to it and pull their code from the remote repository and have it on the local repository. Whatever the changes the user is doing it on the local repository. So that means you don't need to have a connection with the remote repository all the time. Operations normally done is pull, edit, commit, and push. Another concept is of branching in Git, in which the master branch remains the same, and if some developer or a team needs to test a feature, then they create a branch for those specific features and start working on it without disturbing the master branch. Once working on the feature branch is complete, it can be merged back to the master branch. We have a remote repository. Two users are concurrently working on the remote repository. They pull their code and have it on their own local repository and start working on it. Once they are finished with their code, they can push it back to the remote repository, downloading and installing Git. Homepage of Git is git-scm.com. This is the home page of Git. If you scroll down to its download page, let's go to the downloads. We'll be using Linux. The command you need to give is apt-get install git. Before installing any package on your Linux machine, you should give this command of apt-get update. This is updating the apt repository on your Linux machine. Now, in order to install Git, you need to give the command apt-get install git. So the next step is to configure Git with username and email. For that, we need to give this command. Now let's move to GitHub, a slight overview of it and creating an account on Git. GitHub is a repository hosting service. It has a web-based graphical interface, provides access control. It has unlimited public repositories, limited private repositories, and you can have a number of collaborators on the plans which GitHub gives you. and you have organizational accounts option also. For creating an account, go to github.com. You need to give your username, an email address, and a password. In Git operations, what we will cover is, first of all, we'll be initiating a local Git repository, linking it with the GitHub on the internet, adding files, branching it, merging it, pushing it to the GitHub. Let's create a directory, my project. Let's move into it. Yet it will initialize it as a Git repository. So in the Git operations, we have initiated our Git repository. Now we will be linking it with the GitHub. Git remote add origin, and within the inverted commas, we'll give the location of the project. On GitHub, I have created a project by the name of Git training. So this will be the complete command. So your origin has been added, which is on GitHub. This command will pull the repository, which we have mentioned up there. The only file over there was readme.md. Now, if we create a file that is contacts.html, this will be listed in your current folder. Now, the Git status will show you that there is one untracked file, which is contacts.html, which we just created it. Now, there is no untracked file, but there is one new file over there. That means something has been added. It has reached to the staging area. It goes with git commit -m, and in inverted commas, you type in the message what exactly is being done, that you have added a contacts.html file. If we check the status again, so everything is clean over here. You are on the branch master, nothing to commit. There is no any change on your local system which has not been committed. So using the touch command, we have added 2 more files. Now check git status. By giving the command git add -a, multiple files can be added. Now git status shows that these 2 new files have been added. After adding a file, we need to give the commit. Git commit -n and the text. 2 files have been changed. Now shows that nothing is there to be committed. So we have done the adding of files. Now the next step we'll do is branching it. Git branch and the branch name, which I'm using it as branch 1. Once the branch is created, go to that branch, you need to give the checkout command. If we do ls, now we have contacts, people, services. These were the files which we inherited from the master branch, and another file support.html we have created in branch 1. Git status shows you that one new file is created and commit is needed. So in the message we are mentioning it that we have added support.html in branch 1. Now let's move on to master. Now we are in the master branch. If we do ls, here you don't see the support file which was created in the branch 1. So after doing the branching, we'll be merging our branch to the master file. Since we'll be merging the branch into the master, so we need to be in the master branch. With this command, we are merging branch 1 into the master. One file was changed, that is support.html. If we do ls over here, now we have that support.html file here. And at the end, we will push our code to GitHub. We generate an SSH key locally over here, and that public key we will post it onto the GitHub account so that we are able to push our code from the local repository to the GitHub account. SSH key gen will generate those keys. We will copy this key from here. Here on GitHub, we'll go to settings, SSH and GPG keys. We'll add a new key. Just name it as SSH1 and paste the key over here. Finally, add SSH key. In order to test that our keys are working, this is the command we give. You are successfully authenticated by GitHub. The command we'll be needing it is as git push origin to master. So once you have done the push, go back to your GitHub account and Go to this repository, and over here you'll see all the files which were added locally in our local repository has now been available here at Git. So these are the processes which form a Git flow. So in the next video, we'll be on Vagrant, which gives a lightweight, reproducible and portable development environments. Role of Docker in DevOps cycle. In this video, we will cover introduction to Docker, installation and usage of Docker, and role of Docker in DevOps. Starting with introduction to Docker. Docker is an application delivery platform. It's an open platform that helps companies build, ship, and run their applications from anywhere. They are popular because of their flexibility. Complex applications can easily be containerized. They are extremely lightweight. You can deploy updates and upgrades on the fly. Being portable, locally built containers can be deployed anywhere on the cloud or on any other platforms. They are scalable. You can increase and automatically distribute container replicas. Containers versus virtual machines. A container runs natively on operating system and shares the kernel of the host machine with other containers, taking no more memory than any other executable, making it lightweight, whereas virtual machines runs a full-blown guest operating system, taking more resources than most applications need. That's one of the major difference between the containers and the virtual machines. Installing Docker. First, we'll install the curl package, which is done by sudo apt-get install curl-y. This curl will be used to download GPG keys for the official Docker repository, and the command will be something like this. Downloading it from download.docker.com/linux-ubuntu-gpg and piping it with apt-key add so that the keys are added into the apt-get repository. Then we add the Docker repository to the apt sources, which will be sudo apt repository and the following line, which will be pointing the repository to download.docker.com. Let's do it on our machine now. First, we'll install the curl package. Second step is pulling the GPG values, adding the apt repository. Now we will update the app and install Docker C using apt-get update and then apt-get installed -y Docker C. We'll be installing the community edition, which is freely available. Once we do that, we will need to add the username onto the Docker group with the command sudo usermod -ag docker and the user ID. Updating the apt repository. Next, we will be installing the Docker C and adding the user into the Docker group. Running or testing the Docker with the docker -v command. So we have the version 18.03.1 installed on our machine. Next, we will install Docker Compose also, which is a companion of Docker. First, we need to go to its release page and see which version of Docker Compose is available. We are on the page mentioned before, and the latest one available is 1.21.2. Using the current release, we will give the following command to download Docker Compose. This is the command for version 1.21.2. Next, we will set the permissions and move the file into Docker Compose into user local bin. Then we can verify with Docker Compose -v. So we will move into temp and copy Docker Compose into user local bin and change mode it to +x so that making the file executable. Docker Compose -v will give us the version of the Docker Compose. Now, using the Docker. Docker images are available on Docker Hub. Its link is hub.docker.com. We will search the images from Docker Hub and also from command line, starting from Docker Hub. Here I am on Docker Hub, logged in as my user ID, and let's try to find a packages available on Nginx. Now we scroll down and see the top one, the official Nginx available. It has 10+ million pulls. Docker search Nginx. We scroll up a little to the start of it, and here we are. We have Nginx available, which is an official one. Now we'll try to pull in these images. Let's try it with Nginx and with Apache. Docker pull and the package name. Now to see which images we have, We have Nginx, which we just downloaded it, and HTTPD is also available, which I have already downloaded. Now inspecting the images, for example, Docker image Nginx. Docker inspect Nginx, the name of the image. Over here, if we scroll up, the information we are getting, when it was created, the container ID, host name, it will expose port 80 on TCP IP when the machine will be up. And this is the command it will run. I mean, when the container will come up, it will run these commands to bring up the Nginx. Now we'll try to run an image. Docker run -d and Nginx. -d is the detached mode, so that the container kicks off and you get the command prompt back. The container is running, and above is the long string is actually the ID of the container. Inspecting and status of the Docker containers. So these are the commands which will be used to inspect and check the status of the containers. Docker PS will list what Docker processes are running, and this is the first one whose container ID is this one. Its image being used is Nginx. Now inspecting the container by the container ID, you can either use the container ID or the name of the container. Now we have some more information. Since the container is up, the status is running, that is the host name, and then these are the ports exposed, and the important thing over here is the networking. This is the IP address given to this container. Next we are going to do is connecting to the running image. We'll do it with the execute command, docker execute -it. I is for interactive, T is for terminal. Interactive terminal will be available for you, and then the container ID and the application name which you want to run when you are connected to it. Over here we are asking for a bin bash, that is a bash terminal to be available for us. Once we do that, we can go inside the container. We'll run this command apt-get update, install an elinx package, which is a command line browser, and see that Nginx is running on the local host or not. Now you are directly dropped into the container with a root access. It's a very minimal operating system, even PS is not there. First we'll update the apt repository, installing the elinx package. We have the elinx installed and connecting to localhost at port 80 through elinx. That's the elinx message, and there you are. Your Nginx server is running. So how about stopping the container? The command will be simply docker stop the container ID and remove the container. Docker PS will show you that the process is running, one of the containers running. If you need to stop it, the container is stopped. If we do docker PS again, you don't see the container. But PS -a will give you all the containers, the ones which are stopped, which went down due to an error, or the ones which were halted. Everything will be listed. Now we are able to stop it. Now we want to remove it completely. For that, docker rm and the container ID. Now it is completely removed. Give the command of docker PS -a. Coming up to the role of Dockers in DevOps. Container-based virtualization has been widely available for developers who are continually exploring the possibilities of application deployment and reducing the pressure of managing multiple development environments. Docker containers provide the tools to develop and deploy software applications in a controlled, isolated, flexible, and highly portable infrastructure. Docker containers allow the developers to take the risk they want to take, apply the code, move and install new instances, and then roll back to an earlier state if it does not go the way they wanted. Developers can now contain all the runtimes and libraries necessary to develop, test, and execute an application in an efficient, standardized way and be assured that it will deploy successfully in any environment that supports Docker. DevOps is all about automation, and this behavior is widely used in Docker. Therefore, Docker is one of the main tools being used in DevOps lifecycle. In the next video, we will talk about Docker networking. Docker networking. We will cover introduction to Docker networking, some basic networking of Docker, and then we will use the Docker overlay networks using Swarm. Introduction to Docker. Docker containers and services are so powerful is that you can connect them together or connect them to a non-Docker workloads. Docker containers and services do not even need to be aware that they are deployed on Docker or whether their peers are also Docker workloads or not. Whether your Docker hosts are running on Linux, Windows, or a mix of the two, you can use Docker to manage them seamlessly. Mostly used types of Docker networking are basic bridge network, which is a default driver network for all Dockers, and in which application can run in a standalone container that can communicate with each other. Overlay networks are used for a bigger network, connects multiple Docker daemons together, enables Swarm services to communicate with each other. Overlay networks are useful when your hosts are on a different network and containers Docker running on these hosts need to communicate with each other. Docker's basic network. First step, we'll create a network and a volume for which will be used in our Docker containers. We'll start the Docker containers. And the third step, we will test connectivity between these two containers. In the first step, we'll be listing and creating a network. Docker network ls is the command which lists the current existing networks, and then the command docker network create and the network name, that will be net1, which we'll be using. So this command will create a network by the name of net1. Then we'll do the listing and creating of a volume. This network and the volume will be used by our Docker containers. Similarly, in order to list which volumes exist, we use docker volume list ls. For creating the volume, we do docker volume create -- driver local and the name of the volume, which is volume 1. Docker network ls will list the existing networks. So these are the few of the bridges networks which comes in with default. That will be using the command docker network create net1. Net1 will be the name of our newly created network. Now if we list the networks, the second last one is the net1 which we just created. Now moving on to the volumes. Currently we don't have any volume. In order to create the volume, we'll use the same command which we just have it on the slides with the volume 1 as the name of the volume. Now to list the volumes, a local volume is created by the name of volume 1. Now these two, the volume and the network which we just created, will be used by the Docker containers we'll be spinning in the next step. Moving further to the second step where we will be starting the Docker containers. This is the command which we will be running. Docker run will run the container -it. I is used for interactive session and T will give you the terminal so that you can work on it. --name equals the container 1. This is the name which we are giving it to our container, and then the volume which we just created with the -v option, we'll be mounting the volume 1 on /opt inside the container. And then comes the network name. The newly built container will be using the network net1. What busybox is the image of the container. This is the Docker image which will be used to build the container. And at the end is the sh command, that is the simple shell command. Similarly, we will be using the same command with different container name as container 2. Rest of the thing is identical. Now we are on the host machine. We'll run the command docker run to initiate spin of a container with the name docker1. And now we are inside the container. Now using another terminal and running the same command, we are running the second container, which is container 2. Checking the IP address of the second container, we are getting the IP address of 172.19.0.3. The second container is coming out with IP 172.19.0.2. So now we have the two containers running, container 1 and container 2 in the two sessions over there. Moving on to the next step where we will be checking the connectivity between the two. We'll see if we are able to ping container 1 from container number 2 and ping container 2 from container number 1. We'll try to ping container number 2 while we are in container number 1. So we can see that by simply using the name of the container, we didn't have to give the IP addresses. The container already knew the IP address of the second container as it was built and it was on the same network. Now we'll go to container number 2 and try to ping it to container number 1. Here we are on the second container and we'll try to ping container number 1 from here. It is able to reach to the container with the IP address 172.19.0.2. Now comes the overlay network. Over here we have container 1 and container 2, both running on 2 different hosts, and they can be on the same network, on the same subnet, or can be on a different subnet. So in order to communicate between these 2 containers, we use the overlay networking between the 2 containers, and which make it possible for the 2 containers to talk to each other. In the first step, we'll initiate the Docker Swarm, create an overlay network and spin the Docker containers on host 1, spin the Docker container on host 2 and check its connectivity. Log into the container, check its connectivity and ping between the 2 containers. On host number 1, we will check the existing networks and then initiate the Docker Swarm. Docker network ls will list our networks. Docker Swarm init will initialize the Docker Swarm, and then we'll initiate Docker Swarm as worker, which will be running on our host 2, and we will check its networking. We are on host 1 and we list the current existing networks. Net 1 is also there, which we just created in our previous example. We'll initiate the Docker Swarm. So a manager is created, and in order to create its workers or dockers which can join this swarm, we will be needing this command. We list our networks and it's a pretty default values over here. Now we will use the Docker Swarm join onto the second host machine. We are there as a Docker Swarm worker. Okay, in step number 2, we will create the overlay network and spin a Docker container on host number 1. The command we'll use is docker network create -d overlay and the name of the network, that is swarmnet. Attachable equals true. We do it so that any container run afterwards will be able to get attached to this network. We'll list the network and see what has changed over here on host number 1, and then we'll spin a container. So docker run -itd. The extra d over here makes the container run in a detached or a daemon mode. The name of the container will be container 1, and now the network will be used will be swarmnet, and busybox is the Docker image which will be used to spin the container. If we list the networks over here, the last one is the overlay network which we just created by the name of a swarmnet. Now we are running a container by the name of container 1, and the network will be used as swarmnet, and the container Docker image will be busybox. So we have a Docker by the name of container 1 is running. Moving on to the third step, first we'll check the Docker network listing, then spin a container. This command is almost the same as we used before, but over here the container name is container 2. And then finally we will list the networks and see the swarmnet is available over here or not. In host number 2, if we list the Docker network, we don't see any swarm overlay over here, since thing is being using that swarm network over here, therefore it's not available over here. Then now let's spin off a container over here using the same command, container 2 as the name of the container. So your container is running by the name of container 2. Now if we list the containers, we see the last line. Since now a container is running on host 2, which is utilizing swarmnet network, therefore it is visible over here now. Now here in the last step, we will log into the spin containers, check their IP addresses, and see that both the containers can ping to each other or not. On host number 1, we log into the container and check its IP addresses. This is the command which we use to connect or a running container. Docker execute -it. I is again the interactive. T will give you the terminal name of the container, which will be container 1. Then we'll check its IP addresses and try to ping to the other container. Similarly, on host number 2, we log into its container with the same command, docker execute -it container 2 shell, and check its IP address and try to ping the other container. Now again, the scenario over here is that we have 2 containers running on 2 different hosts, which will have a different IPs and can be on different subnets. We are on host number 1. Docker ps lists the running containers. we have container 1 running over here. Now we will try to get inside the container with the command docker execute -it container 1 and the shell command. We are inside the container and our IP address is 10.0.0.4. Now let's go to the second host and try to get inside its container. Here on the second host, with the docker ps command, we can see our container 2 is running. Using the similar command, we'll try to get inside the container number 2. Okay, over here, the IP address assigned to us is 10.0.0.5. So we have two different containers running on two different host machines, but they are on the same network. Now from here, we are on container 2. We'll try to ping to container 1. Ping into container 1, the connectivity between the two exists. Trying the same exercise from the other container, container 1, trying to ping it to container number 2. What we actually did is repeating it again. We have two containers running on two different hosts, which can be on different subnets, but these two containers are being connected to an overlay network and can talk to each other. Coming video will be on Docker deep dive with some use cases. Docker deep dive with some use cases. In this video, we will cover a sample use case. We will start off with explaining the configuration files in detail, and finally run the microservices as Docker containers. The whole process will be a hands-on walkthrough. Our use case is a blogging website which will be based on Docker containers. Website will have 4 containers: Nginx, WordPress, Varnish, and MySQL. Nginx will be a web server and Varnish will be a web accelerator. Our use case will run on Docker images on using WordPress and MariaDB, and then customize images. What are exactly customized images? Customized images are actually base Docker images, and some customization is done on that image, and finally that customized image is used. In our case, Varnish and Nginx will be the customized images. Moving on to the configuration files, we will have Docker configuration files, Docker compose YML, and for Nginx we have a Docker file, and for Varnish again we have a Docker file. Application configuration files will be for Nginx site.conf and for Varnish default.vcl. Now looking into the Docker compose YML file, the first line gives you the version number and then the services are defined. If you see, these files are space or tab separated. Under services, we'll be having Varnish service. For database, we'll be having the MariaDB and WordPress and Nginx. So the first section is for the Varnish. Second, the very first line under Varnish is build Varnish. That means Varnish image will be built over here. Nginx and Varnish will be the two images which will be customized. And then the ports are defined. That means 80 port inside the container will be available as port 80 outside the container. It has a dependency, depends on Nginx. In Nginx section, again, it will be built as Nginx. Restart always is normally required for the Nginx, and volumes from the volume which it's going to get mapped will be coming from the WordPress service. Under WordPress section, image WordPress with the version of PHP 7.1-FPM will be used, and in the next line some environments are being set up. WordPress _db_host, that will be MySQL, the name of the host defined in the services over here, and finally it says that it depends on the MySQL service, the MySQL container. In the MySQL section, Docker image which will be used is MariaDB. Environment is being set up as MySQL root password as an example, and the volumes from where the command will be run have a demo db directory which will be mapped as /var lib mysql inside the container. Normally whenever the containers are brought up and when they are shut down, all the files and the changes which have been made inside the container will be lost. So this information regarding the MySQL, which we will be needing later if we want to restart the containers. Therefore, we map that particular location onto a local directory on the host machine, so that whenever you restart the containers again, the same information which was configured when the last container was run will be available on your local machine, and the newly spun container can use it. Under Nginx, we'll have a Docker file. It's taking the image from Nginx with the version Alpine. Once the image is brought up, then the site.conf inside the Nginx folder will be copied inside the container in the location etc nginx confd default.conf. Finally, in the last line, it copies the default.vcl file under /etc varnish default.vcl, which will be inside the varnish container. And then at the end, it runs this command. It has a huge number of arguments. This command is used to run the varnish d inside the container. Now we will be starting the Docker container. First, we will download the application files from GitHub. In the first line, we are just making a project directory, going inside the folder, and running the git clone command to download the docker_WordPress repository from GitHub. In order to start the containers, we will cd to docker WordPress and give the docker compose command. -f is for the file it has to read, which is dockercompose.yml, which we just had a look at it. Up means containers will be brought up. -d, the container will run in a daemon mode, and whatever is needed to build will be built with the -build parameter. Okay, let's move on to our host machine and run all these commands which we have shown you on the slides. Creating a project directory and cd to the folder. From inside the folder, running the git clone command. So the repository has been downloaded. A folder of docker_WordPress is available now. Going inside the repository folder, docker_WordPress. Here we will run the docker compose command, which will take up the docker compose YML file as a contribution file and start building up the containers which are needed. The process starts by pulling the images one by one and start building it. It will take some time depending upon the network speed. Now it is pulling the WordPress image. Now it's Nginx turn. It will do in two steps. Number one, pulling the image down. It is copying the site.conf file. That is done. Now it is pulling the varnish package. It includes 5 steps. First, it's going to pull the Ubuntu Xenial and then do a number of steps like updating the apt-get and then installing the varnish package inside the thing. Finally, it completed the varnish image, and at the end, you can see the 4 done commands. That means the 4 containers have been created. We can list it by the command docker ps. Here's the list of the 4 containers which are running. Docker WordPress Varnish, Docker WordPress Nginx, WordPress PHP, and the 4th one is the MariaDB, the MySQL server. Now opening the browser and going to localhost. Now you see the WordPress interface. It's asking you for the language settings. Then it is asking you for the site title, username, password, and finally the install WordPress. So it has been installed successfully. Now you can log into it. Giving the required credentials, you can log in. Your blogging website dashboard is available. Now we will try one thing, is that bring those containers down, stop them and remove them, and then try to bring the containers up again. We'll also look into the demo.db directory where some files in the folders have been created, which was created by the MySQL database, so that whenever you restart the containers, that information is available and the new containers can use it. These are the files created under the demo.db, mostly done by the MySQL database, which it will use it on whenever the containers are brought up again. Now let's try to stop the containers remove the containers and then try to bring them up again. First, the process took a long time, but now since the images have been downloaded and has been created, therefore the next one will be pretty much quick. This command will stop the running containers. Containers are stopped. We will remove the containers also, because if we will try to run it again with the same name, it will give an error. So we need to remove them too. So now all the containers are gone. We can check it via docker ps-a command. So none of them are running at the moment. We'll try to rerun them again. To rerun, we will use the same command again, docker compose -f with docker compose yml up -d in the build. Since the images are already downloaded and also built, so the whole process, which took a lot of time before, is not going to happen this time. There you are. We are done within a few seconds. So again, we have the 4 containers running. Let's go to the website again. Refreshing takes you to the login screen. Once you log in with the same old credentials, we are back inside our dashboard. The information which MySQL kept under the DemoDB database folder was useful in bringing up the containers again. After installing and building up the containers, we went to HTTP localhost. We were able to create an account, and then we also explored the DemoDB folder. These were the commands which we used to stop the containers and then remove them and finally build them again. And after doing that, we were able to log in again back with the same old credentials. So the information was kept safe under the DemoDB folder on your host machine. Next section will be section number 3, which will cover the configuration management and clustering in DevOps. Docker deep dive with some use cases. In this video, we will cover a sample use case. We will start off with explaining the configuration files in detail, and finally run the microservices as Docker containers. The whole process will be a hands-on walkthrough. Our use case is a blogging website, which will be based on Docker containers. Website will have 4 containers: Nginx, WordPress, Varnish, and MySQL. Nginx will be a web server and Varnish will be a web accelerator. Our use case will run on Docker images on using WordPress and MariaDB, and then customize images. What are exactly customized images? Customized images are actually base Docker images, and some customization is done on that image, and finally that customized image is used. In our case, Varnish and Nginx will be the customized images. Moving on to the configuration files, we will have Docker configuration files, Docker compose YML, and for Nginx we have a Docker file, and for Varnish again we have a Docker file. Application configuration files will be for Nginx site.conf and for Varnish default.vcl. Now looking into the Docker compose YML file, the first line gives you the version number, and then the services are defined. If you see, these files are space or tab separated. Under services, we'll be having Varnish service. For database, we'll be having the MariaDB and WordPress and Nginx. So the first section is for the Varnish. Second, the very first line under Varnish is build Varnish. That means Varnish image will be built over here. Nginx and Varnish will be the 2 images which will be customized. And then the ports are defined. That means 80 port inside the container will be available as port 80 outside the container. It has a dependency, depends on Nginx. In Nginx section, again, it will be built as Nginx. Restart always is normally required for the Nginx, and volumes from the volume which it's going to get mapped will be coming from the WordPress service. Under WordPress section, image WordPress with the version of PHP 7.1-fpm will be used, and in the next line some environments are being set up. WordPress _db_host, that will be MySQL, the name of the host defined in the services over here, and finally it says that it depends on the MySQL service, the MySQL container. In the MySQL section, Docker image which will be used is MariaDB. Environment is being set up as MySQL root password as an example, and the volumes. From where the command will be run, have a demo DB directory which will be mapped as /var lib MySQL inside the container. Normally, whenever the containers are brought up and when they are shut down, all the files and the changes which have been made inside the container will be lost. So this information regarding the MySQL, which we will be needing later if we want to restart the containers, therefore we map that particular location onto a local directory on the host machine, so that whenever you restart the containers again, the same information which was configured when the last container was run will be available on your local machine, and the newly spun container can use it. Under Nginx, we'll have a Docker file. It's taking the image from Nginx with the version Alpine. Once the image is brought up, then the site.conf inside the Nginx folder will be copied inside the container in the location etc nginx confd default.conf. Finally, in the last line, it copies the default.vcl file under /etc varnish default.vcl, which will be inside the varnish container. And then at the end, it runs this command. It has a huge number of arguments. This command is used to run the varnish d inside the container. Now we will be starting the Docker container. First, we will download the application files from GitHub. In the first line, we are just making a project directory, going inside the folder, and running the git clone command to download the docker_WordPress repository from GitHub. In order to start the containers, we will cd to docker WordPress and give the docker compose command. -f is for the file it has to read, which is dockercompose.yml, which we just had a look at it. Up means containers will be brought up. -d, the container will run in a daemon mode, and whatever is needed to build will be built with the -build parameter. Let's move on to our host machine and run all these commands which we have shown you on the slides. Creating a project directory and cd to the folder. From inside the folder, running the git clone command. So the repository has been downloaded. A folder of docker_WordPress is available now. Going inside the repository folder, docker_WordPress. Here we will run the docker compose command, which will take up the docker compose YML file as a configuration file and start building up the containers which are needed. The process starts by pulling the images one by one and start building it. It will take some time depending upon the network speed. Now it is pulling the WordPress image. Now it's Nginx turn. It will do in two steps. Number one, pulling the image down. It is copying the site.conf file. That is done. Now it is pulling the varnish package. It includes 5 steps. First, it's going to pull the Ubuntu Xenial and then do a number of steps like updating the apt-get and then installing the varnish package inside the thing. Finally, it completed the varnish image, and at the end, you can see the 4 done commands. That means the 4 containers have been created. We can list it by the command docker ps. Here's the list of the 4 containers which are running. Docker WordPress Varnish, Docker WordPress Nginx, WordPress PHP, and the 4th one is the MariaDB, the MySQL server. Now opening the browser and going to localhost. Now you see the WordPress interface. It's asking you for the language settings. Then it is asking you for the site title, username, password, and finally the install WordPress. So it has been installed successfully. Now you can log into it. Giving the required credentials, you can log in. Your blogging website dashboard is available. Now we will try one thing, is that bring those containers down, stop them and remove them, and then try to bring the containers up again. We'll also look into the demo DB directory where some files in the folders have been created, which was created by the MySQL database, so that whenever you restart the containers, that information is available and the new containers can use it. These are the files created under the DemoDB, mostly done by the MySQL database, which it will use it on whenever the containers are brought up again. Now let's try to stop the containers, remove the containers, and then try to bring them up again. First, the process took a long time, but now since the images have been downloaded and has been created, therefore the next one will be pretty much quick. This command will stop the running containers. Containers are stopped. We will remove the containers also, because if we will try to run it again with the same name, it will give an error. So we need to remove them too. So now all the containers are gone. We can check it via docker ps-a command. So none of them are running at the moment. We'll try to rerun them again. To rerun, we will use the same command again, docker compose -f with docker compose yml up -d in the build. Since the images are already downloaded and also built, so the whole process, which took a lot of time before, is not going to happen this time. There you are. We are done within a few seconds. So again, we have the 4 containers running. Let's go to the website again. Refreshing takes you to the login screen. Once you log in with the same old credentials, we are back inside our dashboard. The information which MySQL kept under the DemoDB database folder was useful in bringing up the containers again. After installing and building up the containers, we went to HTTP localhost. We were able to create an account, and then we also explored the DemoDB folder. These were the commands which we used to stop the containers and then remove them and finally build them again. And after doing that, we were able to log in again back with the same old credentials. So the information was kept safe under the DemoDB folder on your host machine. Next section will be section number 3, which will cover the configuration management and clustering in DevOps. Ansible as a provisioning, configuration management, and application deployment tool. In this video, we will cover the use cases of Ansible as provisioning, configuration management, application deployment, and finally, hands-on with Ansible. Starting with the use cases of Ansible, our first one is provisioning. With the help of Ansible, we can provision a large number of infrastructures like cloud platforms, virtualized hosts, hypervisors, network devices, bare metal servers. Ansible integrates with data center tools to invoke and enact the provisioning steps which are required. Large number of available modules gives you the flexibility to manage your diverse environment. Ansible as a configuration management. This is where Ansible is mostly used because of its number one, simplicity. Ansible is very much simple, works on existing concepts, no new knowledge is needed, designated to be minimal in nature, consistent, secure, and highly reliable. It has extremely low learning curve, requires nothing more than a password or SSH key in order to start managing the systems. Ansible was built by developers and systems sysadmins. Shell scripting and command line are the basic tools being used in Ansible. No custom language is needed with Ansible. It uses secure shell, and scripting knowledge is important. You don't have to learn some specific customized language in order to do the configuration management like we have with other tools available in the market. No extra software to be installed on servers also. Ansible as an application deployment. Ansible is the simplest way to deploy your applications. You can deploy multi-tier applications reliably and consistently. You can even configure your services and push your application artifacts from one common system. You can write your custom code as simple tasks to automate your systems. Playbooks are very simple to learn, write, and maintain. You can write your customized playbooks, and then the hard work of getting your systems to the required state, that is being handled by Ansible. By design, Ansible is agentless. You don't have to install any software. It only requires SSH, which by default normally comes with the system. Hands-on with Ansible. Starting with installation, and normally Ansible comes with the normal repository of your operating system. But in order to get the latest and the best one available, you will add this repository, and then with the second command, you will update your apt-get. Once apt-get update is completed, you can run the installation of Ansible. Finally, you can check the version of the Ansible being installed on your machine. In order to get access to your nodes and machines on your infrastructure, you will use SSH keygen command, and then you will use the SSH copy ID that will copy your keys onto your nodes and the machines. That's the only thing you need to do in order to access your nodes. A slight setup is required. All the configuration is by default available under /etc/Ansible. But you can create your own local copy. Going forward, you will be using this location with Ansible. You go inside the local directory and slight changes are required in ansible.cfg, and then few changes in the host file also. Moving on to the host machine, your controller machine is host app, and in our setup we have two nodes, one with the name host 1 and the other with host 2. So we will be managing these two machines, host 1 and host 2, from this controller machine. First of all, we'll use the apt-add repository onto the app database on our machine, and then we'll complete the installation. Then we will run the sudo apt-get update command. Once the update is complete, we will install Ansible. Since we already have the latest Ansible package installed on the machine, version of Ansible is 2.6.3 installed on our machine. In order to generate our SSH keys, we'll run the SSH keygen command. The next step will be copy these SSH IDs to your target machines, which is host 1 and host 2 in our case. So the first command is run SSH copy ID to host 1. It asks for the password, your password on host 1. This will be done only once, and after that you will be able to log into these machines without any password. We'll use the same command with host 2. So we use the same command on host 2, and now we are good to go. As told before, all the Ansible related information, the configuration files are under etc Ansible. So we'll make a copy of that folder into our home directory, and we will use those files for our Ansible. Going into the local directory, and we'll edit ansible.cft file. This is the line we have changed. Inventory equals hosts. That means the host file in the current directory will be used by Ansible. Next, we'll be making the changes in host file. We will give the host names of our node machines in this host file. So these are the two entries we have it in our host file. The host 1 and host 2 are our two nodes. Now moving on to running some Ansible commands. We have installed Ansible, we have done the configuration or localized configuration in your home directory, and we are also able to access the nodes using the SSH command. We are in a position to start using the Ansible commands. Let me define these commands. The first one is Ansible -m ping all. By -m, actually what we are using, module by the name of ping. As the name suggests, it will ping the machines. And all means it will ping all the machines in the host file. In the second command, we are using a different module by the name of shell. With shell, it sort of gives you a shell prompt onto the target machines, and then you can run a command. With -a attribute, inverted commas, you can give the command name. Over here, we are using host name. And finally, all means it will happen on all the machines in the host file. The third command is where when you be needing root privileges. So -k, the capital K, makes you a super user. When you give this command, it will ask you for your sudo password and then continue. Over here, module user we are using, in which we are actually creating a user on those machines by the name of John on all the machines. And finally, as we added the user in the above command, we can also remove that user by giving the state equals absent on all the machines. We will practice this command we just mentioned from our control machine, the master of Ansible. Over here, we are using the first command, Ansible -m ping all, and let's see the result. That's the standard output in color green, ping pong. That means the machine is accessible and it is pingable. Let's try the shell module with a host name on all the machines. So this sort of output you will get. Host 2 is success on host 2, and as well as on host 1 it was a success. And the output of the host command is host 2, the second line from the top, and then for host 1 the second line gives you the host name. So the command was successfully run and the output is also available on the console. Let's try creating the users. Join all 2 node machines. It will ask you for the sudo password, which you need to enter over here. And here's the output. Yellow or orange color is actually represents the changes being done. For example, this command did some changes, therefore it's in this color. Otherwise, if no change was done, then the output is normally in green color. So a user John with home directory /home John with group ID 1002 and UID 1002 is created first on host 1 and then on host 2. Trying the remove command, state making it absent, that means the user will be removed from these machines. So the command was successfully done. It has removed user John from host 1 and host 2. Moving on to roles and playbook. These two give you diverse flexibility on using Ansible. As the name suggests, certain roles are assigned and tasks are assigned along with the playbook. Those roles are activated and tasks are run onto the machines. First, we will create a directory by the name of basic under roles, and then another folder by the name of tasks under it. And inside the tasks, we will create a main.yml file and define what type of tasks need to be done for the roles by the name of basic. So roles having the name basic will perform the following task, which is simply the name for identifying. For example, over here we are installing elinks, and then apt module is being used with arguments package name, which is elinks, and its state, it should be present. We can avoid that, but to be specific, we'll just keep it there as state as present. And similarly, when we need to remove it, the state over here will get changed to absent. Now we are creating the playbook.yml file. The first 3 lines indicates that it's a YML file, and then hosts attribute over here we can either give the host names, or all means this particular playbook will run on all the hosts. Become equals true is needed when you need some sudo access, and then comes the roles. Under roles, we have specified that basic roles will be applied on all the hosts in this playbook.yml file. Running a playbook is slightly different. Ansible-playbook is the command we'll use with -k. Again, sudo password will be asked for it, and then the playbook name. So as per the slides, we have first created the basic directory, under that tasks folder, and then we'll create a main.yml file under tasks folder and define the task needed to be done. These are the entries under main.yml file. Now we are creating playbook.yml file in which hosts are all become true, roles which will be used as basic. Now running the Ansible playbook command, it asks you for your sudo password. Okay, here's the output of the command. First is the gathering facts, some information needed by Ansible that is being exchanged between both the hosts, and then the task basic is run in which we are installing elinks. On host 1, elinks was already installed, therefore it gives an OK sign with a green color, and for host 2 you see a changed message over there with a different color. That means a change was done on host number 2. That means elinks was not already there on host 2. By this command, we are able to install the package on host 2, whereas on host 1, the package was already there. Moving on to items. This is also another useful method being used in Ansible. Over here in main.yml file, we just make few changes. Instead of apt the package name, we just mention item over there, and items are defined with items in the form of columns. For example, curl get and elinks. So curl get and elinks will be installed using this task on which host that will be defined by the playbook, playbook.yml. After making these changes on main.yml, we will run the ansible.playbook-k and the playbook.yml. So these are the changes done on main.yml, where we will be installing packages curl, git and elinks. Now we will run the ansible playbook command. Running the command will ask you for your sudo password. After entering that, the process will start. So here's the output. Gathering fact with green color and then running the task under the basic role. On host number 2, installing curl, git and elinks, and then host number 1, curl, git and elinks. So any of these package were not present in both the machines. So changes was done. So therefore this portion is in a different color with labeled as change. So this was giving an idea of how Ansible works. Previously we just ran it with the simple Ansible command and then we use playbooks. These playbooks are very simple, as you have seen. You can create it as per your requirement, and under the roles you can use the number of modules available with Ansible in order to just use those modules along with the playbook, and you can manage and configure your large number of machines very easily. From here we come to the end of this video. The next following video will be on Jenkins, where we'll discuss the continuous integration and continuous delivery in the DevOps pipeline. This video is on Jenkins. It's continuous integration and delivery. In this video, we'll start with introduction to Jenkins, and then Jenkins helps in continuous integration and continuous delivery. At the end, we'll do the installation of Jenkins. Starting with introduction to Jenkins. Jenkins is an open source automation server, basically written in Java. It's a server-based system. Jenkins helps in building, deploying, and automating any type of projects. Jenkins efficiently manages and controls software delivery processes. Jenkins helps in building, documenting, testing, packaging, staging, and deployment in the software lifecycle. Jenkins monitors code changes in the version control system, and then based on the changes, it takes certain actions. Builds and actions defined in Jenkins can also be scheduled, just like cron job mechanism. Jenkins runs tests and then can take actions, for example, rolling back in case of a failure or rolling forward in case of a success. Jenkins functionality can be extended with plugins. Its URL is plugins.jenkins.io, where you will find hundreds of plugins ready to use with Jenkins. Continuous integration and continuous delivery are the main jobs of Jenkins in the life cycle of DevOps. Now coming on to continuous integration. What is continuous integration? Merging all developer work copies to a shared mainline several times in a day. Previously, this integration was not done as repeatedly as it is done today. Then they started doing it once or twice a day, but in DevOps, it's mainly done many times a day. Continuous integration prevents integration problems, which can turn out into an integration hell, which used to happen in the past. Good practice is that each developer must do a complete build and run all unit tests before submitting. Once the developer has run its unit test before submitting it, integration tests are later done by the continuous integration server. Jenkins as a CI tool, it is the most popular CI tool. It offers a simple way to set up a continuous integration pipeline. It automates routine development tasks. Jenkins gives a faster and robust way to integrate entire chain of built-in tests. Jenkins has the ability to control and monitor the jobs and tasks defined in its system. With the help of Jenkins built-in pipeline plugins, you can create multi-stage jobs and visualize it. Coming up to continuous delivery. What is continuous delivery? It's a practice where code changes are automatically built, tested, and prepared for a release to production. Continuous delivery expands on continuous integration, deploying all code changes to a testing and/or a production environment. It provides developers with a deployment-ready build artifact that has passed through a standardized test processes. Continuous delivery provides developers automate testing beyond their unit tests. These tests can be UI testing, load testing, integration testing, API reliability testing, etc. In continuous delivery processes, Jenkins is the most widely adopted solution for continuous delivery. Jenkins is the glue that allows you to bring both CI and CD together. Jenkins has more than 1400 plugins that enables it to use best of the breed solutions throughout the continuous delivery processes. Moving on to installation of Jenkins, we will do it on Ubuntu 16.04. First of all, we will add the repository keys and the URL to our system. wget from https pkg.jenkins.io/debian/jenkins.io.key and add that key to our local repository of the machine. Once that command is done, then we add a line for the location of Jenkins Debian stable version under jenkins.list. The second command does that. As a normal practice, once you add the list, you need to update your apt repository. First command is doing that, and after that use the install Jenkins command to install the Jenkins package. Jenkins need Java on your system. If Java is not already installed, you might get an error. Normally Java is installed on the machines. Once the installation is done, now you have to open your browser, and the default location to access the Jenkins application will be localhost port 8080. Once you go to localhost or 8080, you'll come up with the unlock screen. Its password is located in the operating system under var lib jenkins secrets initial admin password. You need to use this to log into Jenkins GUI as an administrator. That is the location of the file. You need to cat this file and copy the password from there into the above GUI. The next window you will get for customizing Jenkins. So default one is install suggested Jenkins, and the second option is for the advanced users. So you click on to install suggested plugins and the installation of the plugins starts. This will take few minutes until all the installation is complete. After installation, you will be prompted with this window. You need to create the first admin user, give a username of your choice and some secure password, full name and the email address. Once you do that, you can move forward. After this completion, the Jenkins is ready and you can start using it. Clicking onto the start using Jenkins, you'll be given up with the Jenkins dashboard. In the next video, we'll be configuring Jenkins with Git. Configuring Jenkins with Git. In this video, we will cover a walkthrough of a sample example, and we'll see how we can integrate Git with Jenkins. Integrating Git with Jenkins. We'll start with our Jenkins server up and running. Git is already installed and user has a repository. We will set up the Jenkins with the local Git repository such that when a commit is done on the repository, some tasks are performed by Jenkins. Then we will manually do some changes on the repository. A commit will be performed, and then we will monitor the Jenkins job which we were assigned for the particular task and see what happens. We'll start with populating the repository git clone from this location. That's a sample Java project. We will remove its .git folder and then initialize it from the beginning. Git status will show that a lot of changes are there in the repository which need to be submitted. Git add will add those changes. And finally, we will commit it with the comment as my first commit. Now we will set up the job on Jenkins. Going on to localhost at port 8080, select the new item. This window will appear. We will enter the project name as Java project. Out of the different types of the projects, we start with freestyle project for this example. After that, we'll click the OK command. A new window will pop up. Under journal section description, we will type anything. I have written testing over there. Under the source code management, select Git and paste the repository URL, which is local on your machine. For credentials, click Add. This will open up another window. Keep all the values the same, no need to change anything, and then click Add again. That will take you back to the old window. Under Credentials, select this syntax and click the Add button again. Scroll down under Build Triggers. What kind of triggers you want to configure? Select Full SCM. Select the schedule for per minute. Under the Build section, we are planning to execute a shell script, and from the shell script, we will run few commands, selecting the Execute Shell from this drop-down menu. So under this window, it's asking you which command do you want to run. Over here, we are just taking the log of the Git. Actually, this is the place where you can do a number of things. For example, if a commit is done and you want to use that version, you can extract the version from git clone, use it for deploying the application. If it is running some containers based on those configurations, you can spin up those containers and do number of tests to make it sure that things are gone fine. So in this command window, you can have number of commands per line base. After doing that, you will save it. Let's go to the dashboard and I'll show you over there what kind of configuration is done for the Java project. Clicking on to the Java project over here. Now go to the configure on the left side. That's the first section of description where we just testing over there. Scrolling down to source code management, we have selected Git and repository URL is given over there. Credentials are set according to what we did on the presentation. Scrolling further down under build triggers, we have poll SCM with schedule with 5 asterisks. Finally, the build section under execute shell, the command we are using is git log. So this is the setting which we have done onto our Jenkins server. Okay, coming back to our presentation, now we will be triggering the Jenkins job with a commit. Going to Java project folder and we just echoing testing to a test file. Then we will check the git status, add it, and then git commit with -m with the command as my second commit. After that, if we need to monitor the Jenkins job, the build history, you will see something coming up. The logs are coming up. Let's go onto the machine and try those commands. We are now on the console. We went to the Java project folder. In that folder and echoed testing on that file. Then the git status shows us that there's a modification in the test file, which we added it with the command git add. And finally, at the end, we are trying to commit these changes with the command my second commit. Once we have done the commit, now we'll go to the Jenkins page. Here you see a job running, job number 8, just kicked in. Once that is complete, we'll check its logs. Output shows that it was an SCN change. The commit message, my second commit, is also there. So these are the logs of Git, which shows that this particular commit was done. And the console is displaying this messages because under the command, we gave the command to run, which was git space log. So these are the git logs being seen over here. Coming back to our slides, same type of output is over here also when the second commit was done. So this is how the whole procedure happened when Git was configured with Jenkins. It was a local repository. When a change was done, Jenkins was monitoring the change on that repository and it was pulling it after every 1 minute. As soon as it came to know that commit has been committed, it runs the script on the command line which we had given. That was git log. This was the example of SCM is triggered where we only give the command of git log, which we ask Jenkins to run git log command only. From here you can do a lot of number of tasks assigned to Jenkins and that can be performed automatically. Our next video will be on Kubernetes, managing containerized workloads and services. This video is the last video of this section, which is on Kubernetes, which is being used for managing containerized workloads and services. In this video, we will cover introduction to Kubernetes, its key components, studying the architecture of Kubernetes, and finally, a hands-on by running locally. Starting with introduction to Kubernetes, portable, extensible, open source platform used for managing containerized workloads and services. Facilitates declarative configuration as well as automation. Provides container grouping, load balancing, auto healing, and scaling features. Moving on to the key components of Kubernetes pod. It's a group of containers. Labels are used for identifying the pods. Kubelets is a container agent. Proxy is a load balancer for pods. etcd is a metadata service. C-Advisor is the container advisor which provides resources, usages, and performance statistics. Replication controller manages replication of pods. Scheduler schedules pods in worker nodes. Nodes are the slave machines. API server is the main application of Kubernetes. Moving on to Kubernetes architecture. Kubernetes follows a client-server architecture. Single master server, but can have multiple masters set up for high availability. Master servers acts as controlling node and point of contact. Then we have some master node components and node components, which we'll discuss in the coming slides. Master component. This is an image of Kubernetes master also. It has a components of etcd, scheduler, controller manager, and API server. etcd is a simple distributed key value used to store cluster data, API objects, service discovery details. It's only accessible to the API server. No other services or the nodes can access it. Kube API server is the front end to the cluster, a central management entity which receives all our REST requests for modifications. Make sure data is stored in etcd. Then comes Kube Control Manager. It runs a number of distinct controller processes, regulates shared state of the cluster, and perform routine tasks. Controller spots the change and starts working to get the new desired state. Kube Scheduler. It schedules the pod on various nodes based on utilization. It knows the total resources available and also the ones already allocated to the running workloads. Node components, starting with kubelet. It's a main service on the node. All the communication is done through this service. It ensures that pods and their containers are healthy and running in the desired state. Reports to the master on the health of the host which it is running. Kube Proxy runs on each worker node, deals with individual host subnetting, and exposes services to the external world. Performs request forwarding to the correct pod containers according to various isolated networks in a cluster. Pods. These are group of containers. It can be one or more of them. The specification for how the container is run. Containers within a pod share an IP address and port space. Applications with a pod always have access to shared volumes. Container Advisor. It provides resources, usage, and performance statistics. It collects, aggregates, processes, and exports information about running containers. Let's try our hands-on by running Kubernetes locally. Let me introduce you with Minikube. It's a tool that makes it easy to run Kubernetes locally. Runs a single node Kubernetes cluster. Useful to try out. We'll be using it in our exercise of hands-on today. First, we'll install Minikube. Just curl it from storage googleapps.com Minikube release latest Minikube Linux AMD 64 and then copy it under user local bin. Then the other important tool, which is kubectl. These two tools will be mostly used. Now setting up the environment. Few environments are required, which will be done. Making a directory, config file. That's the last command with which we can start the Minikube. This is a for loop, waits until the kubectl can access the API server that Minikube has created. This for loop will be run. Once that is done, now you are able to interact with the cluster. We can start the cluster with Minikube start, running a eco server pod using kubectl. That's more or less similar to the syntax which we have been familiar with Docker. And port 8080 will be used and the image will be kts.gcrio/ecoserver with the version 1.4, and then we'll expose the service. Check pods if it is running or not. We'll start with the dashboard to view our pods and the cluster which is running. Once you give this command, default internet browser will open and Kubernetes dashboard will be available to you. Now we are on our Linux machine. First of all, we will install Minikube. Running the same command, this will curl the Minikube binary. Minikube is done, and now we will install kubectl. This will take a while. So kubectl is also done. Now setting up the required environment. After doing that, we can run Minikube with this command. Now it is starting the cluster components. Now running the for loop is done. Now starting the Minikube. So the local Kubernetes cluster is running. Now with the help of kubectl, we'll run a container, echo server version 1.4, running the second command of kubectl. Now it is exposing the container. Checking if the pod is running. Yes, it is running. Now it is time to run the dashboard using Minikube command. Kubernetes dashboard will come up on the default browser. Here you can see the Kubernetes dashboard with the deployments, pods and replicas. Under the deployments, you can see that Hello Minikube is also running. So it gives you a very exploratory type of dashboard also, through which you can deploy your pods also. You can schedule them, replicas, duplication, you can do it, and you can very well manage the loads from here also. And finally, at the end, you can stop the Minikube by the stop command. That clears up the Kubernetes cluster. Our next section will be on monitoring solution provided in DevOps. Monitoring solutions in DevOps. In this video, you will learn DevOps monitoring solution using Monet and Negius. In this video, we will cover starting from introduction to monitoring, important practices, and then moving on to the tools. Monet as a monitoring system, Negius as a monitoring system. Starting with introduction to monitoring. Service monitoring. For example, if you have few services running like a web server, you need to monitor it and check whether it is running fast. Is it actually giving the results what the user is looking for? If someone tries to log in, is your login authentication working? Any errors are being generated? So whatever your site or your services are meant for, are they giving the right services to the user or not? For that, you need these monitoring services. Operational monitoring, in which your hardware is working or not, your servers are up, there's no downtime to the services. For all these, you need tools, and automated tools will be a great help. So for example, you have dozens of servers, but they are serving only few users. So that means your system is being underutilized. So you need to monitor your resources and the usage. Finally, therefore, you need monitoring services. Moving on to important practices. Collecting the data. You cannot manage what you cannot measure. You need to take inventory of what is being collected. Analyze the inventory collection, what data to be added and what to get removed. How information is collected, through which means and processes you get the data. This is all important in collecting the data. Correlate and diagnose. Data simply does not help you. You need to correlate it with the needs and goals. Do some comparison against the different incoming matrices. Establish baselines for basic service availability. Define it thoughtfully. Constantly ask what the organization is missing from the data. Relate it to business initiatives. Identifying trends. Examining the historical data to identify previous trends and take actions before issue arises and customer complains again. Establish alerting threshold on these trends by outlining what is normal and alerts on violation of these normal values. Notify and act using automation. In manual mode, a notification is delivered and then the team reacts. But you can have solutions to many problems which can be done automatically. For example, a disk full. Certain logs fill up the space which can be removed. So automate this removal. You don't have to wait for the alert to reach the team and then someone logs into the system and does the bug fix. Before stepping into automatic solutions, you must understand where it is best to add automation. Moving to a faster process means a shift from a manual to automated processes. Coming on to Monet, the monitoring system. What is Monet? A free open source process supervision tool. System status can be viewed directly from the command line or via a web server. Fairly uniquely suits the needs of the Ruby and Rails community. As the Ruby and Rails community grew, same happened with Monet. Many popular Rails sites have used it, including Twitter and Scribbly. What Monet can do? Monet is proactive. It can act in an error situation. For example, mail server program is not working. Monet can simply detect the issue and restart it. Web server is not responding. Monet can stop and restart it. Monitor process characteristics such as how much memory is being used or CPU statistic. It can monitor processes, daemon processes or programs. Even system boot processes can also be monitored from Monet. It can monitor files, directories and file system. For example, for the changes like timestamp changes, checksum errors, size of the file, any change in the size, any access time on the files or directories. Useful for security reasons. It can monitor MD5 checksums of the files and monitor if any change is being done. And if any change exists, it can alert the system. Cloud and hosts. It can monitor network connections to various servers, which can be local or remote. TCP, UDP, and Unix daemon sockets are supported. Network tests can be performed on a protocol level. Built-in tests for the main internet protocols can configure Monet to send any data and test the response from the server. Test programs and scripts. Test programs or scripts at certain times, much like cron. It can test exit value of a program and then perform an action. Sends an alert if the exit value indicates an error. You can write scripts for any type of checks. Monitor the systems. Monitoring the general system resources like CPU usage, memory, and load averages. Moving on to Nagios monitoring system. What is Nagios? Nagios is a free and open source computer software application. It was originally designed and run under Linux. It monitors systems, networks, and infrastructure. Offers monitoring and alerting services for servers, switches, applications, and services. Alerts when things go wrong and alert back when the problem is being solved. Moving on to the features of Nagios. Comprehensive monitoring. It monitors applications, services, operating systems, network protocols, system matrices, and infrastructure components. It has a powerful script APIs, allows you easy monitoring of applications, services, and systems. Visibility and awareness. Centralized view of the entire monitored IT infrastructure. Detailed status information available through web interfaces. Fast detection of infrastructure outages are also available. Alerts can be delivered to technical staff via email, SMS, or other alerting tools. Escalation capabilities ensures alert notification reaches the right people. Problem remediation. Alert acknowledgements provide communication on known issues and problems response. Event handlers allow automatic restart of failed applications and services. Proactive planning. Trending and capacity planning add-ons ensure you are aware of aging infrastructure. Scheduled downtimes allows for alert suppression during infrastructure upgrades. Reporting. Availability reports ensures SLAs are being met. Historical reports provide record of alerts, notifications, outages, and alert response. Third-party add-ons extend reporting capabilities. Multi-tenant capabilities. Multi-user access to web interface allows stakeholders to view infrastructure status. User-specific views ensures clients see only their infrastructure component. Customizable code. It's an open source software. Full access to the source code and being released under GPL license. Next video coming up will be on setting up and configuring Nagios. Setting up and configuring Nagios. In this video, we will cover starting with downloading and installation of Nagios and a slight setup and configure. Coming up with installation of Nagios and startup. Let's have a view of the Nagios website and see what do we have it there. The website is nagios.org. Nagios is an open source software. It has a core version in which you can download and install it, which gives you the core monitoring engine and a basic web interface. Then you have the Nagios core plugins. You can download these plugins, which will be used for monitoring the systems and the infrastructure. These are about 50 plugins, and then you have some front ends, different flavors which you can use it, and then some add-ons. Nagios core latest is something 4 version. Apart from that, they have Nagios XI, Nagios Log Server, and Nagios Fusion. Over here in this tutorial, we'll be exploring Nagios core. Some of the prerequisites for Nagios. It needs an Apache server and PHP. Those two will be required. So before we do any installation or downloading, we will try to fulfill these prerequisites. First of all, on our Ubuntu machine, we will make it sure that our apt repository is up to date. Then we are going to apt-get and install Apache 2, its libraries, mod for PHP, and PHP version 7. These are the prerequisites for Nagios. There are some system dependencies and utilities. Since you'll see in the coming slides, we will be downloading the source files of Nagios. After downloading those source files, we'll be configuring and installing the package. For that, we will need some system dependencies and utilities, which we are going to install it beforehand. That includes wget to download the utility, unzip to unzip the packages, autoconfig, gcc, lib6, make, Apache 2 some utilities. These are the utilities and dependencies which will be needed, and we will going to install them before. Creating a user. This will be the user which will run the Nagios application. User add, simple user add with Nagios, and then we will add it to the Nagios group with www-data group, which is part of the Apache, because Apache and Nagios, they are going to interact with each other. Therefore, they should have some common rights. Moving forward, downloading Nagios from the website, going to nagios.org. On the main page, to Nagios core download page, then there's another download page, and it will ask you for some information which you can put it over here. It has an option for skip. You can skip and move ahead. Version 4.3.4. You can download it from their website or by using the wget command and the exact link over here. https assets.nagios.com/download/Nagios core release Nagios core 4.3.4.tar.gz. So it will be a tarball file, gzip. Once we unzip it, that will be a source file which we will have to make and install. Extracting the Nagios tarball once the download is complete. Tarx zf, z is for compression, f is the file, and x we are extracting it. Once we have extracted the file, the directory by the name of Nagios-4.3.4 will be created, and we will cd into that folder. Now configuring Nagios. If you are familiar with the source files and the source repositories, so we'll start with configuring it. Once we configure, we have to make it sure that we configure Nagios with Apache site enabled directory configuration. That is the switch we are using in this command line. Once we do that, we need to build the Nagios files. That will be done by make all. That, if you remember in the beginning, we installed a package. So that is why we installed it in the beginning, where we'll be needing it over here. Once we do that, we will be installing the binaries. Sudo make install using sudo, because the installation will be done in the root areas under user local folder, which a normal user cannot write it. So you'll be needing sudo access to it. Once you do that, you will be installing Nagios init daemons, some external command mode configuration files, and enable Nagios daemon system-wide, so that whenever the machine comes up, Nagios comes up. That's the install init. We are installing it, and then the install command modes, and finally through systemctl we are enabling Nagios service. Installing Nagios sample configuration files. Sudo make install config. Some of the config files which will be needing it, we are just installing it in the beginning. Installing Nagios configuration files for the Apache web servers. Since they both interact with each other, Apache will be the front interface. We are installing the webconf, creating Nagios admin account with a password so that Apache server can log into Nagios web panel. So that will be done using htpassword command, sudo htpassword -c user local Nagios etc htpassword.users space Nagios admin. That will prompt you for the password. Give a password which should not be very easy one, but you should be able to remember it or write it down for future references. Allowing Apache HTTP server to execute Nagios CGI scripts and to access Nagios admin panel via HTTP. For that, we will enable CGI module in Apache and restart these services. This command will help us do that, and then restart Apache server and then the Nagios, enabling it system-wide. So almost everything is done. Time to log on to Nagios web interface, and the URL for that is http://localhost/Nagios, or the IP address. In place of localhost, you can have the IP address over there. Now let's move on to our Linux machine. We will do the hands-on installation of Nagios, starting with sudo apt-get update. Once the update is done, we will install the prerequisites of Nagios, which is Apache and PHP. This will do the installation. After installing the prerequisites, we are going to install the system dependencies and the utilities. This will take a while. Next is to create the user Nagios. The first command creates the user Nagios, and the other one is adding it to the Nagios group and www-data. Now we can download Nagios from this website using the wget command. The package is being downloaded. Okay, the file was downloaded, and then we use tar command to extract the tarball. After extraction, we cd to the Nagios folder. Starting with the configure command. After the configure command finished, it gave us this general options, which will be helpful for us to know. We'll be using it in the future. Our next command was make all. The GCC compiler is building the application, and finally it will create the binary files which we will move it to the operating system. Our binaries are built. Now we'll move it to our required locations. We'll do that with sudo make install. The binaries will be installed under the local operating system. That will be user local Nagios folder. Here we ran the three commands in which Nagios init was installed, and then command mode was also installed, and finally systemctl enabled the Nagios service for the system. Installing Nagios sample configuration files. Now in Nagios configuration file for Apache web server, using htpassword command and creating a user Nagios admin. New password is created, reprompt was done, and similar passwords were added. Apache HTTP server to execute Nagios CGI scripts were allowed from the first command, and then the Apache and the Nagios systems were restarted. We are almost done with the configuration and installation of Nagios. As time to go to its web interface. That will be http localhost/Nagios. It will prompt you for the user ID and password, the Nagios admin which we created. You will need to provide the credentials over here. So we are logged into our Nagios interface. So our Nagios server is running, version 4.3.4. Coming back to our slide, this is the dashboard of Nagios monitoring services. Our following video will be on the infrastructure monitoring using Nagios. Infrastructure monitoring using Nagios. In this video, we will cover continuing the configuration and the setup of the Nagios server, and then we'll see how Nagios monitors the infrastructure. and how the clients are configured so that it can communicate with the server. Setting up and configuration continues with server. We left our video from this slide when we were able to log into our Nagios core. Process ID was running, everything looks fine. But on the left column, if we click onto the hosts, we see a list of local hosts over there, but a bunch of errors. In the status information, you can see some errors are visible over there too. Status of the machine also shows it down. Why is it so? This is happening because Nagios plugins are missing. We haven't yet installed Nagios plugins on our server. For that, I'm going to install Nagios plugins. It has some dependencies which we need to install them first. Sudo apt-get install, and all these dependencies will be installed using this command. Then we need to download the plugin from sources. And move on to your home directory. And then wget the file. The release 2.2.1.tar.gz is the latest plugins file which we are going to download. Once the file is downloaded, we need to extract the plugin source code and then build it. tar xfz will extract the file, z will unzip it, x will extract it, and f is for the file. Let's compile and install these Nagios plugins. Cd to the release directory, running the setup command first, then configure, building and making the binary files, and finally installing those binaries onto the operating system. Nagios plugins are installed under user local Nagios libexec folder. You can ls and navigate that folder and see how the plugins are structured over there. Once the Nagios plugins are done, we need to restart the Nagios daemon. That can be done with the systemctl restart nagios.services command. Now, if we go to our page, and we will be able to see that the errors which were seen before are no more there. Now we have the Nagios plugins there. Moving on to configuring the clients. We'll start with configuring CentOS machine as a client. It needs some installation on the machine, and then some configuration will be needed on the client side as well as on the server so that both the machines can talk to each other. EPL repository configuration we need to update since default repository doesn't have the information and the location of Nagios client which we will be installing. So EPL repository configuration will be updated from here. Moving on to installing the NRP add-on and Nagios plugins. yum install -y-nrp and the Nagios plugin all will help us do it. Once the installation is done, now we need to configure NRP add-on and add the IP address of the server so that client know where my server is. Vi to the nrp.cfg file, and you need to add the IP address of the server under the allowed_host line. Just write a comma at the end and add the IP address. Configuring Nagios checks. etc nagios nrp.cfg file contains some basic commands to check the attributes that include the CPU utilizations, swap area, memory, hard disk space. Lots of commands are over there. You can run a couple of these commands and make it sure that you are getting the results. These results will be sent to the Nagios server, and that information you'll be able to see it on its dashboard. Run those commands and test it. Get the feeling that what type of outputs you'll be getting from these commands. Starting and enabling NRPE, systemctl start NRPE, systemctl enabling it. Now, moving on to the server, so that we need to do some configuration over here for the remote clients. Create a command definition to use check NRPE plugin. For different plugins, we need to make some alterations. Vi command of CSG file and add the following lines to that file. That's a simple syntax which will be needed. The command lib64, that means your machine is a 64-bit. For 32-bit, this will be different. Adding client Linux host to Nagios server by creating a client configuration file. Under the etc services folder, vi this file. We are creating this file and populating it with the following information. Hostname, alias, you can put it anything. It's an alias to that. Then the IP address is important. Now verifying for any errors. Just to confirm that our configuration files are properly set up, before we restart our Nagios server, we need to verify it. That will be done with this command, and then finally we will restart our Nagios server. Now let's move to our Linux machines, first the Nagios server, and install those Nagios plugins so that localhost checks can be viewed on its dashboard, and then we will bring up our CentOS machine, configure it for a client. Moving on to our Nagios server, installing the dependencies, sudo apt-get install. These are the dependencies required to install the Nagios plugins. Our dependencies are installed. Now we will download the latest plugins from Nagios link. We went to our home directory and giving the wget command. The file is downloaded. Now untar it and we will move on to its release folder. After extracting and going into the release folder, we will use the setup and configure commands. That's the setup command running. Now the configure, make and then sudo make install. This will install the created binaries into our operating system. So the plugins are over here under user local Nagios libexe folder, and you can check around with these checks how these checks are configured. We have the plugins installed, and now we will restart our Nagios service. Let's move on to our web interface and see what's the status over there. Perfect. Status is up, and under the status information you can see that ping is also working. All of the statuses are okay. Now let's move on to our CentOS machine. This is our CentOS machine. For the EPL repository, we need to run this command. Then installing the two packages. We add the nrpe.cfg file and add the host IP address over there under allowed_host line. That's the line where we have added the IP address. Testing a check which was listed nrcp.cfg file. So this is a user check where it says that 2 users are currently installed. So this type of information will be then passed on to the Nagios server. Now restarting nrpe and enabling nrpe. We are done with the configuration of CentOS client for our Nagios server. Now we'll move on to our Nagios server and add some information over there so that the server knows that to which client it needs to connect to. Adding the commands.cfg file, adding the last 4 lines at the very end of the file. Under etc services folder, we are creating CentOS_client CFG file, and we'll populate it with the information regarding our CentOS client box. Adding this information along with the hostname and the IP address, that is 192.168.10.155. After setting up the client information, we need to check that our configurations are running okay. Going ahead and restarting the server. Now let's move on to our web interface and refresh the page over there. Here on our Nagios server, and we see that OS boxes, which was our Linux CentOS client, is also available over here. Both the localhost as well as the OS box is configured and running in the dashboard. The next section will be section 5, which will be on DevOps best practices and security. Section number 5, DevOps best practices and security. Our first video in this section will be on best practices in DevOps lifecycle. Listing some of the best practices. It's a cultural change which the teams need to adopt. Then comes the version control. Everything should be under version control. Test-driven development is a very important key point for DevOps lifecycle. Automation. Everything should be automated as much as possible. Choosing the right tools. Documentation. Documenting everything and securing the infrastructure. Coming on to the first one, DevOps as a cultural change. Successful implementation of DevOps means that all teams should concentrate on collaborating as a single unit. We need to forget about the silos and work as one collaborative team. It is not the people and their roles. It is an actual change in the way you think about how things are done and the outcomes. You need to do things better. In order to grow exponentially, communication and collaboration becomes a key factor in DevOps culture. Collaborating between what? Is it between the development and operation teams only? Which is important. Rather, with the business teams also. That greatly helps to understand, to design and define a culture. Then comes the marketing and the sales teams also. Aligning all parts of the organization helps to get closer in projects and achieving the goals collectively. Like in a cultural change, if DevOps is implemented step by step with input from all teams and stakeholders, then the chances for success are drastically improved. Teams are working together, no blame game. It's a collective and a collaborative effort in which the DevOps implementation can be successful. Version control. Everything should be under version control. Every stage of DevOps lifecycle must be version controlled. It's not only the source code of the application, which is a must. In building environments, everything should be scripted and saved in the version control system. You should check out from the version system and then run those scripts to bring up the staging or production environments. Even the development environment must go through the same path. Testing steps, scripting, and building up the test environment should also be under the version control. Same should follow for all these steps and phases of DevOps lifecycle. Test-driven development. It is one of the best practices being used in DevOps. It is based on incremental testing and repetition of a very short development cycle. Developers write the automated test codes with inputs, errors and outputs, known errors and outputs, and then these automated tests normally fails at the first run. The developers start writing the code. As they write the code, they test it with the automation tests. Fix the code until all the tests are passed. Now clean up the code. So this process is being used, and finally it refactored the code. Automation, a key factor of DevOps lifecycle. It gives you speed. Important aspect of DevOps is speed. Therefore, application automation is always good to use. Reduces errors, costs, and time. This saves a lot of time of team members. Manual work takes a lot of time, and possibility of human error are always there. Automation directly helps in reducing the cost of the project and save money for the company. Automation reduces the burden of manual work. You can do anything manually, but that time can be used to focus more on development. Routine and redundant work is once played under automation, gives more time by putting energies in development. With huge collection of Jenkins plugins, automating builds has become much faster and easier. Its integration with version control system and then option for triggering tasks independently as well as in a sequence helps in building automated pipelines. Starting from builds, setting up staging production environments, testing, delivery and deployment, each step should adopt automation, leaving a minimal or no space for manual work. Choosing the right tools. Check for your requirements, what is needed, which type of tools will be used, and check its compatibility. The tools are compatible with your requirements or not. Evaluate the tools available. Once you finalize the tools, make it sure that your teams get stronger in using those tools. As long as you don't have the full grip on those tools, you won't be able to make the best use of it. Prefer most widely used tools. This is because a lot of work is being done on different tools, and the tools which has maximum number of plugins available and supports are available, that will help you to cover a lot of areas of your software lifecycle. So better prefer those tools which are being widely used. Moving up to documentation. Everything needs to be documented. All the work you do must be documented. It can be reports, change management, processes, infrastructure, layouts, the pipelines which you have been using, DevOps lifecycle, everything should be documented. This will help in making your automation processes more efficient, and if there are any flaws or any shortcomings, you will be able to make them efficient. Whenever there are changes in your team members, this documentation will always help the new team members in learning your system. Securing the infrastructure. Compliance from the beginning. If your team follows certain compliance from the first day, then there is very less chance to compromise on your data. Set up routines to verify your vulnerabilities in your infrastructure. Use security best practices. This should not be avoided. Get some pen testing on your application as well as on your infrastructure. Make it a routine. This practice should be done after every 6 months. These were some of the best practices which a DevOps team in an organization must adopt in order to attain very workable environment of DevOps lifecycle. Our next video will be on security best practices in DevOps. Section number 5, DevOps best practices and security. Our first video in this section will be on best practices in DevOps lifecycle. Listing some of the best practices, it's a cultural change which the teams need to adopt. Then comes the version control. Everything should be under version control. Test-driven development is a very important key point for DevOps lifecycle. Automation, everything should be automated as much as possible. Choosing the right tools. Documentation, documenting everything, and securing the infrastructure. Coming on to the first one, DevOps as a cultural change. Successful implementation of DevOps means that all teams should concentrate on collaborating as a single unit. We need to forget about the silos and work as one collaborative team. It is not the people and their roles. It is an actual change in the way you think about how things are done and the outcomes. You need to do things better. In order to grow exponentially, communication and collaboration becomes a key factor in DevOps culture. Collaborating between what? Is it between the development and operation teams only? Which is important. Rather, with the business teams also. That greatly helps to understand, to design and define a culture. Then comes the marketing and the sales teams also. Aligning all parts of the organization helps to get closer in projects and achieving the goals collectively. Like in a cultural change, if DevOps is implemented step by step with input from all teams and stakeholders, then the chances for success are drastically improved. Teams are working together, no blame game. It's a collective and a collaborative effort in which the DevOps implementation can be successful. Version control. Everything should be under version control. Every stage of DevOps lifecycle must be version controlled. It's not only the source code of the application, which is a must. In building environments, everything should be scripted and saved in the version control system. You should check out from the version system and then run those scripts to bring up the staging or production environments. Even the development environment must go through the same path. Testing steps, scripting, and building up the test environment should also be under the version control. Same should follow for all these steps and phases of DevOps lifecycle. Test-driven development. It is one of the best practices being used in DevOps. It is based on incremental testing and repetition of a very short development cycle. Developers write the automated test codes with inputs, errors and outputs, known errors and outputs, and then these automated tests normally fails at the first run. The developers start writing the code. As they write the code, they test it with the automation tests. Fix the code until all the tests are passed. Now clean up the code. So this process is being used, and finally it refactored the code. Automation, a key factor of DevOps lifecycle. It gives you speed. Important aspect of DevOps is speed. Therefore, application automation is always good to use. Reduces errors, costs, and time. This saves a lot of time of team members. Manual work takes a lot of time and possibility of human error are always there. Automation directly helps in reducing the cost of the project and save money for the company. Automation reduces the burden of manual work. You can do anything manually, but that time can be used to focus more on development. Routine and redundant work is once played under automation gives more time by putting energies in development. With huge collection of Jenkins plugins, automating builds has become much faster and easier. Its integration with version control system and then option for triggering tasks independently as well as in a sequence helps in building automated pipelines. Starting from builds, setting up staging production environments, testing, delivery and deployment, each step should adopt automation, leaving a minimal or no space for manual work. Choosing the right tools. Check for your requirements, what is needed, which type of tools will be used, and check its compatibility. The tools are compatible with your requirements or not. Evaluate the tools available. Once you finalize the tools, make it sure that your teams get stronger in using those tools. As long as you don't have the full grip on those tools, you won't be able to make the best use of it. Prefer most widely used tools. This is because a lot of work is being done on different tools, and the tools which has maximum number of plugins available and supports are available that will help you to cover a lot of areas of your software lifecycle. So better prefer those tools which are being widely used. Moving up to documentation. Everything need to be documented. All the work you do must be documented. It can be reports, change management, processes, infrastructure, layouts, the pipelines which you have been using, DevOps lifecycle, everything should be documented. This will help in making your automation processes more efficient, and if there are any flaws or any shortcomings, you will be able to make them efficient. Whenever there are changes in your team members, this documentation will always help the new team members in learning your system. Securing the infrastructure. Compliance from the beginning. If your team follows certain compliance from the first day, then there is very less chance to compromise on your data. Set up routines to verify your vulnerabilities in your infrastructure. Use security best practices. This should not be avoided. Get some pen testing on your application as well as on your infrastructure. Make it a routine. This practice should be done after every 6 months. These were some of the best practices which a DevOps team in an organization must adopt in order to attain very workable environment of DevOps lifecycle. Our next video will be on security best practices in DevOps. Tools for security checks in each cycle of DevOps. Yet another cultural issue. You need to build motivation in DevOps team to use security in DevOps cycle. Integration between the tools of security and development should be improved and adopted earlier in the DevOps lifecycle. By using effective and timely security tools of DevOps, make production code in a much better position to handle real attacks. Test-driven development is giving way to a more business-focused version of creating application requirements based on user needs. It's known as behavior-driven development. The technique mines user stories for cases that can be implemented and tested. While many of these tests validate the behavior of a program, a variety of open source security focused frameworks are available as well. Starting with Gauntlet. It focuses on Ruby development. Gauntlet is a ruggedization framework that enables security testing that is usable by dev, operations, and security. Mitten is used for Python development. Mitten was originally inspired by Gauntlet. It is an evolving for security testing tools. to be run on continuous integration context. Once the initial set of tests is running in test automation, new security test cases can be added based on existing ones without having to understand exactly how the tool are set up and run. BDT Security. It's a free and open source automated testing framework run on continuous integration server as part of the build, test, deploy processes. It can generate reports to be viewed and understood by business as well as security users. Tests are run dynamically against a deployed application. Some pre-commit security tools. This includes some security activities tools before code is checked into a version control system. GitHound. It's a form of a security hook. GitHound is a free security tool meant to help reduce some of the risks by providing automated checks to ensure sensitive data isn't committed into code repos. OWASP Threat Dragon. Threat modeling is widely regarded as a powerful way to build security into the design of applications earlier in the development lifecycle. It is free, open source threat modeling web application for teams implementing the Stride approach. Sonalet is an IDE extension that helps you detect and fix quality issues as you write the code. It works like a spell checker. Some of the features are bug detection. It benefits from thousands of rules. Instant feedback, on the fly, issues are detected and reported as you code. Precisely pinpoints where the problem is and gives you recommendation on how to fix it. PumaScan, it's another IDE security plugin. It provides real-time continuous source code analysis for C# applications. Vulnerabilities are displayed immediately inside the development environment. Continuous integration security tools. Discussing some of the fast automated security checks during the build and continuous integration cycles. ESLint. This tool is used for static code analysis in which computer programs debugging is done by examining the code without executing the program. ESLint is an open source JavaScript linting utility, has a command line interface. Code linting is a type of static analysis that is frequently used to find problematic patterns or code that does not adhere to certain style guidelines. The primary reason ESLint was created was to allow developers to create their own linting rules. Mocha is a feature-rich JavaScript test framework running on Node.js and in the browser, making asynchronous testing simple and easy. Mocha tests run serially, allowing for flexible and accurate reporting while mapping uncatched exceptions to the correct test cases. OWASP Dependency Check. Dependency Check is a utility that identifies project dependencies and checks if there are any known, publicly disclosed vulnerabilities. Currently, Java and .NET are supported. It has a command line interface, a Maven plugin, an Ant task, and a Jenkins plugin. It automatically updates itself. Dockerbench. It is a script that checks for dozens of common best practices around deploying Docker container in production. Dockerbench is also available in the form of a small container. Some continuous delivery security tools. Here we are listing checks before, during, and after code is deployed in production. SSL Lab Scan. Basically for security smoke tests. It's a command line reference implementation client of SSL Lab APIs, which are designed for automated and or bulk testing. SSL Lab APIs expose the complete SSL or TLS server testing functionality in a programmatic fashion, allowing for scheduled and bulk assessments. OSQD. For safety checks, OSQD is a great option. OSQD uses basic SQL command to leverage a relational data model to describe a device. Frequently, attackers will leave a malicious process running but delete the original binary on the disk. This query returns any process whose original binary has been deleted, which could be an indicator of a suspicious process. OS query is released under the Apache license. Ansible Vault. It's a feature of Ansible that allows keeping sensitive data such as passwords or keys in encrypted files rather than plain text in your playbooks or roles. These vault files can then be distributed or placed in source code control. Samhan is a host-based intrusion detection system, provides file integrity checking and log file monitoring analysis, as well as rootkit detection, port monitoring, detection of rogue SUID executables, and hidden processes. It has been designed to monitor multiple hosts with potential different operating systems, provides centralized logging and maintenance, although it can be used as standalone application on a single host. Operation security tools. Operations of continuous security monitoring, testing, audit, and compliance checks. Some of them are starting with Chaos Monkey. It injects faults to make the system resilient. Chaos Monkey was invented in 2011 by Netflix to test the resilience of its IT infrastructure. Chaos Monkey randomly terminates virtual machines, instances, and containers that run inside your production environment, exposing engineers to failures more frequently to build resilient services. OpenSCAP ecosystem provides multiple tools to assist administrators and auditors with assessment, measurement, and enforcement of security baselines. Provides a wide variety of hardening guides and configuration baselines, ensuring that you can choose a security policy which best suits the needs of your organization. Grafana. It's an open platform for analytics and continuous monitoring. Grafana allows you to query, visualize, alert, and understand your matrices no matter where they are stored. It creates, explore, and share dashboards with your teams. ElastAlert, another tool for continuous monitoring. ElastAlert is a simple framework for alerting on anomalies, spikes, and other patterns of interest from data in Elasticsearch. It works by combining Elasticsearch with two types of components, rule types and alerts. Elasticsearch is periodically queried and the data is passed to the rule type, which determines when a match is found. When a match occurs, it is given to one or more alerts, which take action based on the match. With this, of section number 5 and the course concludes. I hope you must have enjoyed the course.